music should be considerably lower now, and the volume of the mic should be just as it was before. I can also try bumping it up a little bit. Let's see how that works. One, two, three, 1, 2, 3. Is that better? Uh-huh. Let me see. Because over here, I've got it at 0, right? 0 decibels. And I've got the music, the desktop audio at like -30. So when I see the volumeters going up, right, it really looks like there is... Oh, it might just be the case that I'm looking farther out. How about now? Is this better? I feel like maybe the directionality of this thing is too directional. So when I look to the side, right, if I have the mic very close, then it doesn't really pick me up. But if I have it closer by or further out, right, then it does. Okay, cool. I've had this microphone for, I don't know, 12 years now. You would think that I know how to use it by now. Yeah. Cool. All right, I posted on Twitter that we're live. I think I'm just missing the LinkedIn message. So I'll do that real quick. And we are go. I think, all right, we are live. Dev tools. I hate that you have to do all this hashing of things in LinkedIn for messages to get anywhere. Maybe I just don't know how LinkedIn works. Cool. That is sent over there. Right. Let's get started. So we've been building the Q programming language. Just a quick intro, so if you're picking this up later on YouTube, you get what's happening. This is a little language that began with a little rant, or really a joke, earlier this year on Twitter, where I was saying that I would like a language that has all of these characteristics, right? And a little bit tongue-in-cheek, just saying please and thank you. Like Ron Swanson from Parks and Rec. It's supposed to have things from OCaml, such as the type safety, right? The kind of scalability that has made Erlang well known for like real-time, low latency systems. A powerful macro system like the one of Racket, right? And the overall developer experience that you've come to expect of Rust. So super friendly, but also super malleable as a language. You can build a lot of things, but also safe, and also can scale very well across different cores and things like that. And two more things were added to this list. One very recently that I am going to pick, but one of them was the ability to build the kind of tooling that we have in languages like Faro, right? And if you're not familiar with that, you can just go to Faro Lang, I think .faro.org. That will be the website, and you get this beautiful immersive programming experience. Where everything that you're doing is within a running program written in Faro, so you can modify not just the programs that you use to program in Faro, but also Faro itself from within Faro. And if that sounds bananas, is because it kind of is, right? The entire language has access to the entire language, which is kind of beautiful. Super powerful thing. You can do crazy things with the sort of reflectivity. Fuck, is that the right word? I'm forgetting right now. Reflection. Yeah, it's reflection, right? Yeah. The reflectivity of the language. So the language can, for example, query all of the objects that it currently has running and get all the classes and get all of the methods and messages those classes respond to, right? And do things with that. And there's a couple of interesting talks about what FP could learn from small. I think that's a small detour, but interesting. YouTube, what FP can learn from small talk. I remember this talk being pretty interesting. We're not gonna watch it right now, though. Sorry about that. Yeah, and in this talk, Aditya Sriram walks us through the kind of things that you can do with Faro. So if you're interested in learning more about what I mean when I say the ID tooling of Faro, then have a look at this. This is pretty amazing, the things they're doing here. For example, I don't recall exactly what they're doing here, but this is being built with data from all the subclasses of something, right? I guess it's a set of all the methods, right? Of all the subclasses, and they're being grouped somehow and then being displayed right within Faro itself, right? It's like if you're writing a JavaScript program and then you say, okay, please list me all of the modules that I am currently requiring, right? And then find all of the functions those modules export, right? And then I want to draw those with a Canvas API, that sort of thing. It's pretty amazing for those kind of explorations. So that was the one thing. And then the newest thing that I said I would like to consider is Camille Schmielewski. I need to get him to get them to tell me how to pronounce that. Saying that maybe we want the portability of JavaScript, right? So yeah, this would be a language that needs to compile to WebAssembly then. And I think that would fit right in with DX of Rust. That makes it very straightforward to compile to different platforms, do cross compilation. So this is what we're up to in a very long-winded sort of tour. We've got a tiny repo that we've set up, and over the course of the last few streams, 3 streams, right? We've started from scratch, so you can go back to the commits here and sort of see like, okay, we bootstrapped the repo, we began the lecture, we began the parser, we did a couple of fixes, right? And just yesterday, I did a small fix on the little captain's log that we're building for this. That says, okay, these are the sort of, oh, 2112, hey, amazing, I love that number. It haunts me, it's following me everywhere. That's a story for another time. But every stream we've sort of had this little to-do list that we tried to go through and so on. So the next steps that we had defined for this stream would be to have a look at how to do skip ahead when we have a parser error, and then defining the smallest set of constructs that would actually make Q a Turing complete language, right? If we get that in place, then we can start playing around with the macro expander, because we would have a tiny language that I don't even know if we'll be able to do something meaningful here, but at least we'll be able to pave the way, right, for more features to be used within the macro expansion phase. So that's sort of where we are. Let us begin. So I'll just start first. A new entry here. Captain's log, start date, 24th of August, 2022. And we'll grab these next steps and we'll actually turn them into to-dos. Wait, nope, what did it do? Captain's log, there you go. Cool. So, going through the actual code that we wrote, we had a very, very basic CLI application, right? That when you run, you can feed it a bunch of files and it will go through every file and actually instantiate a parser for that file, parse the thing, and then try to get diagnostics out of that. And diagnostics in this case will be a result that if it's an okay, then we'll have nothing in it. If it's not, then it will blow up with some errors. And we had a small test file here that we could run to to see what the diagnostics look like, right? So in this case, it's saying, hey, we were parsing this module, we found a declaration without a value, and it's showing us that it's line 3 of main.q here. This error is not amazing, but it's a start, right? And it will help us just go through and add more context. To be able to do that, we had to go from, and maybe we can just do a quick drawing of this, right? We had to go through a couple phases, right? So we started with a little Q file here, right? That is just a string. And then we push this through a lecture that actually grabs the file, the string sort of, and chops it down, right? So you get all the input as a string and you chop it down into small tokens that represent something. You don't yet know what those tokens are or what they mean, right? In conjunction with each other, but you know that they exist. So one example of that, showing code here, go to token, would be the equal symbol, right? Or the question mark, right? We're sort of saying, when you find this little character, then turn it into this piece of data, right? Then we're grabbing this outputs as tokens, right? I'm just gonna pick a different color here. Let's see how awful this one is. That's all right. And we push this through the parser. And this doesn't happen literally in this order, right? The parser actually has a lecture inside. But essentially, the tokens go through a parser and come out as a tree. And that tree is something that we are just starting to build out. So I have to figure out how to do a tree here. Drawing cute little things is not my specialty. But I guess that we could try. So the output of the parser will be a tiny little tree. And does that look like a tree to you? Almost looks like a funky cloud. Or like a bomb or something. Not a fan of this drawing. Look at that. Came here for the programming languages. Stayed for the drawing of the trees. Anyways, so you get a tree there, right? This is really unimportant. And this is our parse tree right now. And this is how far we've gotten. What we would like to do is include in the lecture these tokens that we have here. Tokens. And in our parse tree, more things than we currently have that would allow us to write a program, right? That we would know as humans that this would be Turing complete, right? That if you were to evaluate this according to certain semantics, which we have not defined yet, right? Then this program, there will be no way of knowing whether this program actually ends, right? Okay, so this is where we were. So we had the lecture, and the lecture is defined here with all the tokens, sort of wrapping the token data structure. And then in the parser, we actually create a lecture, right? The moment we start the parsing process, and we sort of go through all the tokens, try to make sense of them. Cool. So let's look at the parse tree. The parse tree looks like this right now. This means every one of our modules has a bunch of module items, which can be value declarations right now. And every value declaration, right, will have a name and will also have an expression. And right now, the only expressions that we can define are literal strings, right? So I think the easiest way that we could turn this into a Turing complete language would be to allow for the user, the programmer writing this code, right, to loop somehow, right? And as a functional programmer, when I say loop, I mean recurse. So I would like to be able to call a function, right? To have a function call of some sort, right? Which also means I will need to be able to define a function of some sort, right? So we're gonna say function here, and there will be a way of defining the function. And it will be an expression because we want functions to be first class, right? To be values. Actually, I don't know if that makes sense right now, because it's enum if is of the things that we want to be able to bind to declare as values. And a call here may not be something we want to do at module level, right? So if we go back to our Q file, right, maybe let's say that we have a function called like print somewhere, right? And this thing takes some arguments like, I don't know, name, right? And does something with that. We can ignore that for now. Maybe we don't want to, at the module level, say, all right, I'm gonna declare something that will just be a function call, hello, right? Maybe that doesn't make sense. I'm also tempted to do, maybe just because we were looking at small talk, but I am tempted to do something like this, right? For call syntax, right? So where you have the name of the function, and then you just have the arguments, and the arguments are all named as well by default. I don't know. We will definitely have to play around a little bit with the syntax, but the point is, as long as we can define a function and define a way of calling a function, we'll be able to say f, right? And f will be a function, right, that just calls itself. Voila! And then we have something that, if you look at it, right, you wouldn't know if we will finish. I guess in this case, it might be easier. We can just look at this and say this function is just calling itself. So we can tell that this is not total, right? Let me try to get some syntax here. Like this is definitely a partial function. Is it a partial function? Would that be the name we would use for this thing? Something that never finishes. Non-terminating, maybe? Yes. That'll be a start. Okay, I'm getting pinged on Twitter. Okay, so let's go for now with a regular, like, boring call convention, right? Where we're saying print, that's the name of the function, parentheses, and then we have arguments separated by commas. We can maybe change this later. We'll see. Because right now we're just dealing with regular functions, and maybe we want to be able to associate things with another kind of structure, like an actor, right? Say actor or process. Actually, proc would be nice for process. So then we can say this process responds to certain messages, and those messages are just functions that receive a context, which will be the internal state. But, you know, like, maybe we're getting ahead of ourselves. We will evolve the language at that point. Okay, so let's go for this. Let's say that we will actually make these two things happen. This would mean, for the time being, the parse tree would allow for certain trees that are just not valid, right? That we would have to actually fail on. So if somebody makes a module where they define a value to be equals to a function call, right? We will just say, yeah, you cannot do that. Function calls are reserved for, right? Sort of to be within other expressions. But then again, maybe that's fine. Maybe we can use that function call as a macro invocation. So if you're trying to call things, right, then at that point in time, they will be evaluated as macros rather than regular functions. We will see. Okay, let's start. So what do we need for calls? We need to have a number of arguments, right? So args, and this is going to be a vector of expression, right? And we will also need to have an identifier. So who are we actually calling? We can do fun here, right? And say ID. And when we are defining a function, we will need to have a couple of things. We will need a name, right? And that will be an ID. And we will want to have a couple of arguments that are being defined. So this will be an expression and a vector, but it will not be expressions themselves. It will actually be patterns. We haven't really talked about pattern matching, but we will soon enough, I guess. Right now, I think we could do this as an empty num. And then we would have a body, right? So long as functions are defined with a single clause. We may actually want to define clauses separately so that we can say, here's a collection of patterns, right? And it corresponds to a body, but if you have multiple collections of bodies, that can be dispatched to different bodies, right? So I guess the question would be, would we want to do something like we have in Erlang, right? Where we say, when the argument is 1, then run this thing. But if the argument is, anything else, then don't run that. Do something like true. I wonder what this will look like. Not very fond of vertically aligned languages like that. I like more dense languages in general. Okay, I do want this because I really enjoy how working with clauses, right? Pattern matching by clauses helps me build certain programs with very sort of keeping the logic at the function definition level. Like when you're writing a parser, for example, if you wanted to do something like, let's say we have a syntax for matching on strings, and it will be something like, I don't know, ampersand, and then you say, okay, I'm gonna say get, right? Let's say that we're trying to match on an HTTP header, and then you just want to capture the rest, right? So then here you could have the code that handles get, right? And then if you wanted to do a post, you could do just that. And this function will be the same function, right? F. Oh my God, I'm running Erlang again. No. But would that be so bad? But if you do the equals in the middle, then all of a sudden you get this sort of, I guess mentally I'm just thinking, I need these two things to be indented in the same way, right? To be sort of structurally within F rather than F being defined multiple times. Which maybe that's what we want. Okay, so let's do something. For the time being, we're gonna work with a single clause, but we are actually going to have a single clause, right? We're gonna support multiple, but we're just gonna use a single one of them. So this will be fun clause. It's a very funny clause. So pubstruct fun clause. We might actually change this. And here we'll have an expression. And I think that will be fine because we have an indirection in the middle, right? We're not actually putting the clauses there. Sorry, it's not like this where we have a cycle, right? We have the indirection of a vector, so that should be fine. Cool. Okay, so have we broken anything with this? Cargo test, go. Nope, that looks good. let's see if we can add some, not to the lecture, let's add some tests here. So we have that works fine, and we actually have this as well, function call, so that should be okay. We have Lexian support for what we want to add, so we just need to add it to the parser now. So we're going to add a couple of tests for this thing. And at some point it'll be easier to just use a library for snapshotting, right? Where we can define all of these little bits of Q code, right? In different files, run the tool and just dump out the AST, for example, to match, to save the expected AST and then compare and say, oh yeah, this has been broken or not. But right now this is quick and fast enough for us to get it done. Okay, so we want to parse a module with a function definition, which I don't think we have. So we'll say print, right? And this will be just empty right now, doesn't do much. So I expect that to fail. Cargo test, actually parse module or function. Cool, parser 182, we're there. Diagnostics, there's a bunch of diagnostics. Oh my goodness, 4 of them. Why? Missing value. This is no bueno. Why did we do that? Isn't this? Oh, wait, of course. When we're trying to parse an expression, we're only saying, hey, give me a little literal string. We're not actually parsing functions right now. Yeah, that's the one thing that we want to add. So I'll just close this stuff. Cool, so we want to parse first a function definition, which means when we are writing the parser here, and we want to parse an expression, we're going to say, if the token, right, I guess the current token. This is, I think we might want to pick instead of next here. If the token is going to be brace left, what do we have? Parents left, right? If the token is a parenthesis that's open, then we know there's a couple of things that we will be, able to parse at this point. So we'll go straight into parse function, right? So self, the parse function, and we're going to pass in the lecture. Yeah, I think I'm going to turn this into peak. We just look at what the next token is, right? Some rather the reason I would like to have peak there instead of the next is that I would like to define parse function to expect the first token, right, the current token, to be an open parenthesis rather than assume that it already has been parsed. So here we can do lecture expect, right, token parents left, and then eventually parents right, and then eventually we'll get the brace, right? So I think this will make it easier to understand what the parsing of one function looks like, right? You give a lecture and it says, okay, first of all, there has to be a left parenthesis, right? There has to be a right parenthesis at some point. Here in the middle, we will try to parse all of the arguments, right? So we will have something like args and then parse function arguments, right? Lecture. And we won't And then in here we will actually have the body, and the body will be parts expression, right? So by the end of that, we will have a function. We will be able to say, okay, right? And where's the parse tree? Parse tree. Actually, when we do parse function, we will want to say self parse function clause, right? And we might want to parse several function clauses until we are out of those. Right now, I'm just going to put that there, and I'm going to move the body of this function around. There you go. So every function clause will have these things, right? Expression, actually, fun clause, parse error. So okay, fun clause, and this will have args and body, right? And that will be that. And we actually can get the body, but for args right now, we're just gonna do an empty vector. And why are you complaining? What are we missing here? One parents too many? Yeah, there you go. Cool. Right, so if later on we wanna accept more clauses, then we just have to figure out here how to say, okay, if the next token, right, when we do a pick is a semicolon, for example, assuming we use that to separate clauses in a function. If it is a semicolon, then recurse, right? Like consume the semicolon and recurse. If it is not a semicolon, then grab all the things that we've been building, right? Parsing all the clauses and put them together into a single function. But right now we just have a single clause, right? So we can do that. And we'll just return okay, func expression, function, right? And this will be a name, which we don't have because we are actually getting the name from the value declaration. Okay, fine, you win. We'll do that right now. So maybe we don't actually need this to be that. Clauses. Okay. So that makes some sense. I'm tempted to just do the multiple clauses here, but the only thing we need to change now is how we parse an expression. So here we're going to do pick instead, right? And what we want to do is to unwrap this. So I actually wonder, I mean, we definitely don't want to unwrap, right? We want to be able to sort of more gracefully handle this, but we expect there to be a token. Because if there is no token, when we call next, then we will get this parser error, which means that we are sort of done. There's no more things to be done. If we don't, then we have to wrap all the stuff in sum, right? And then say, well, when there are no more tokens, then we'll actually return a parse error saying end of file, because that was the end of file. So I'm not very fond of. Okay, let's go with this for now. And I guess this is breaking because we will have just a reference, right, to that token. Yep, yeah, we would. Right, you will be cloned right now, and will deal with you later. Cool. So we just need to make these two things public for now. Amazing. Different error. Things are looking better. I'm actually gonna declare beam vacuum group C and open these things again. Cool. So what's the problem now? Line 201. Still the same. So we expected some ID, but instead found brace right. I'm sorry. What? This should have, if we print out the tokens from the lecture as they're being pumped out, peak take lecture, I think we can't do that easily anymore, unfortunately. Then we would expect right. So in this case, we are picking only on the token, but we're not actually consuming it, dropping it, right? It's there, and only when somebody calls expect or next, right, they will actually use it. Actually, I don't even know if expect will be the right one. I think it would, yeah, because expect relies on self next. So this will just do the same thing that we expect it to do, right? Okay. But here, when we're parsing the literal, and we definitely want to move this into like a parse literal function, right? Where just grab all the literals and just drop them in there. Here we would have to say, okay, we get it. You've seen a literal, right? Now actually consume that literal. So I remember in the lecture, or maybe even the parser for caramel, I had a nice little way of just saying like commit or next, right? Okay, so that's the same thing. Great. Why am I dropping that there? Is the parser next function? Okay, so this is just moving the next token. It doesn't actually give me the next token. That was the difference here. So I have to use peak to actually get the current token all the time. No, never mind. I'm just going to t current span token, and that's the current token. And if it is something I want, then I just go next, right? So it gets consumed and so on. I actually like that. It's I think a very imperative way of thinking of the problem or the solution, but it's pretty straightforward to understand, like, where are you as you start walking, saying, okay, current token is equal, so drop that, right? Current token now is something else, and so on. Don't know how that'll scale, but yeah, we sort of want to just do that same thing. We want to say, hey, like, drop that token. I guess the problem now would be that because we're picking, we actually have a reference to this thing, right? Which means if we were to call lecture.next here, we would get an actual error saying, nope, you cannot have exactly. Borrows. Ay. Oh no, running out of coke. Low on fuel. So what do? Do we make peak return a copy of the token? So it solves the problem of borrowing there. Do we come up with a new abstraction for this? Something that would allow us to pick without actually duplicating the tokens every time we're picking. I think right now it would be okay for us to say here's the peak thing. And that would be that. Right, so all of these tests, they don't need to dereference anymore. They'll just do. But we don't want to call next like that, right? We want to call next like that because we already have the token. And we don't need the cloning there. Fine. Okay. So what does the error say? Still, missing value, invalid declaration. Unexpected symbol found, expected ID found, brace right. Okay, so where are we expecting an ID? I'm confused because we pick on the expression and we go there, parse function clause, we consume these tokens, brace left, brace right, right? And in the middle, we're actually parsing the expression. I think we cannot parse nothing, maybe? Is that the problem? No. Maybe it is. Okay, so who is saying unexpected symbol found, right? Only parse ID. And parse ID is only being called here at the beginning. Screw it. I think I'm just gonna debug the tokens picked, and then we're gonna say token. Equals left, right, left, right. Why is the last brace right peaked? Parse function, clause. Okay, because we go in here and we peak. Interesting. So we won't be able to to sort of just return error there, unless this actually is an error in the parsing, right? If the program we're trying to parse here just doesn't make sense, and we want to have like an atom or something like that. Yes. So the obvious thing here is that calling parse expression when we don't have anything will actually yield an error, and then this will return from this function, which will return from this function, which will return from this function, which will go all the way to the value here, and it will map that error using a missing value invalid declaration. And that's the error that we're seeing here, missing value invalid declaration, with the span and the stores, right? And I don't actually see the error here. And I think that's what's bugging me, because the immediate thing that we see, right, is that this continues to run because we're parsing as many module items as we can, because we're not out of tokens yet. We're just pushing diagnostics, right? So we'll have to either get by without defining a body for functions right now, or allowing functions to have an empty body, or forcing the function to have some body, right? And the body will be, at the very least, a single token, a single expression. So I think having something like an ID would be fine. I don't think I'm following why that will be failing right now. Because in here, if we say hello, right? Then in any other language, this will be like saying, oh yeah, return the value of this variable that is not bound to anything, right? So we can later deal with that error, because we may not know where this is defined, or may not want to deal with that right now. So I would expect this to go all the way into parse function clause, go through the left and right parentheses, left brace, go into parse expression, right? And get out of there with an expression from here, right? That actually is, and nope, of course, this is never going to happen there because we don't have an ID, right? As an actual expression. Okay, but before we do that, just to get it working with a minimum amount of code, we're just going to use a literal string, right? Okay, all right, that makes more sense. Value declaration, we have one value declaration there in the middle. It's a function that has single clause, that has no arguments, and the body is a literal string. All right, so the problem was that we were trying to parse an expression that we didn't support yet. And in the right hand side we have the expectation, which is just wrong. Cool. So that's fine. I'm just gonna grab this thing and gonna replace this vector with that. And I might have to do toString and toString here as well. And I think some things will be broken. And value declaration, I think this is module item. We're missing field, value, and I guess function. This will be expression, and here will be vec, and here we will have vec as well, and this will be expression. 2 arguments. Valid declaration. Yeah, I think that's fine. Maybe we have a few tokens or missing a couple of tokens. So that's that. That's that. Ah. I did something to my smart parenthesis support. There you go, that worked. And now it's just not working as it used to. So I'm noticing that I'm having this error over and over. Like I see a string and I go here and I do like, oh, to string, right? Okay, now it worked. That's fine. But I am ending out without that extra parenthesis. Cool, so we have that works fine. And then we're gonna parse a module with a function call. So here we're actually gonna say print. And I expect that to fail. Excellent. So we see the right thing. We see parentheses, left, right, brace left, an ID, parentheses left, right, and then the brace. And yeah, this is fine. We just need to go into parse expression and actually add here that if you see an ID, then this may be a function call. We'll probably have more logic than just this here, right? Actually, we're just gonna parse function call. Do that, delegate. And what we want to have here is we want an ID, and this will actually look very close to the value declaration, right? We'll have a name, and we'll expect some tokens, right? And then we'll have to parse all the arguments that go inside, which we don't have those yet. So we'll expect the parents left, right? And then we'll expect parents right, and we'll expect some arguments, right? So that we don't yet have, but this will essentially be a list of a vector of expressions, right? And we will return an expression at the end that will be call, and this thing will have an ID and some arguments, which right now is going to be empty. So we'll start with that. What's wrong with my call? Fun. Not ID, fun. Actually, I think I'm just gonna call it ID. Cool. Compile, run, test, fail for me, please. Thank you very much. We're not really using the var name in here. It would be useful later to be able to pick more than one token ahead, right? Say, oh, what's the next token? That's an ID, perfect. What's the token after that, right? Is it a parentheses, yes or no? Don't know how much of simplification that will be right now for this. In any case, we should have now a call, perfect, here on the left. We get a call to this thing, which is great. So valid declaration, ID print, we have an expression here. The expression is going to be call, right? And I think, yeah, this will just be braces, and we'll say the ID will be ID of print string, and then the arguments will be an empty vector. So I think that should pass, and it does. All right, I think we have imbued our language with a very, very small but powerful thing. We can define functions, and the functions can call each other. Not that any of this actually runs yet, but one thing at a time. Captain log. Still not very powerful, right? It doesn't do much. But if we had a runtime, then I would expect us to be able to call this function, right? And for it to just run forever, never end. Just keep running and running and running. Cool. What else do we have here? We would like to work on the macro expander. Yeah. I think we might want to push that a little further up and define some more things in the language that can make it a little more useful. Because if we had something like pattern matching a list, right, then we would be able to use the recursion and pattern matching, right, to establish arbitrary control flows. Not that we have any kinds of data that we can use to pattern match on, but it would be a start. So let's do a little bit of that. Let's define multiple clauses, right? And let's define pattern matching, or I guess add. So if we can get some of that in place, then we'll be able to write some tiny programs. And the reason I'm saying this is that if we have some tiny programs, if some tiny programs can be expressed in Q, then we can use that language, right, to evaluate, right, the macros. Because we would have to figure out how to make the macros do things, right? And I think one easy way to do this would be to just use the same language that your program runs on to run the macros, right? So we would have to add support for like a quote and unquote. And I don't know if these will be expressions themselves. Maybe they will. Yeah, and in quoting, for example, you will just get like a vector of tokens. Maybe unquote is not going to be an expression, but quote will. We'll see. I can borrow some of the things I was working on in Caramel for this. But the idea here would be that you can use this expression language, right, to actually operate over these tokens, to produce a new series of tokens that we will try to parse back into expressions, right, that we will eventually execute. So having a language that can actually be used for something like this would be pretty useful. Otherwise, we're going to be sort of stuck. So, for example, in Caramel, was it the 2? No, Macro Expander 1. Yep, second version never got anywhere. But this bad boy is sort of a macro expander, right, that works over the parse tree. So in the parse tree here, in the new syntax, we actually have a kind of expression which is a quasi-quote, where we have lists of tokens that you can then operate on, right? And then you can unquote expressions directly or do an splicing unquote. Um, so the macro expander, oof, if I remember this thing, it's been a while, will find all of the bindings for macros that you're defining across your code base, right? And then evaluate those, just expanding them, and they can be expanded as annotations if they are part of the structure of the module, right? Or they can be expanded as expressions, but they begin sort of as annotations. So when you expand annotations, then first you will only derive the annotation macros, and then we actually derive all the other annotations. Am I reading this right? First we run all the derive annotations, and then we run all the other annotations. So some of the examples we have here in, I guess, tests. I'm in the wrong folder. Macros for control flow, for example, right? You got this little macro here, and I think I can do Rust, and it will be clear enough. So you're defining a macro, and you're using language for defining the macro, and it's my hope that at some point maybe this language will be the same language that Caramel actually runs. So I think we can borrow that idea. And then when you go into the main function, right, and this looks like Rust intentionally, you actually will evaluate all of these compile time things, right, at compile time. So when you compile this file, the macro expander will identify that this is indeed a macro, right? And it will grab all of these inputs and it will just call that, and it will just keep evaluating things, right? So here we get the condition and we get what to do on true and false, right? And it quotes and unquotes accordingly. And then we have another macro here that actually uses pattern matching, right? Just a match expression to say if the step is 0, then we're just going to return this list, right, of the atom done. But otherwise, we're just going to return a quoted expression, right, where we're going to unquote the current direction, right, and then just start pulling down or decrementing the steps. Eventually, we will get there. But this ... unquote is sort of what gives us the ability to concatenate, right, all of the different lists that get generated by the macro expander, right? And the macro expander is really just an interpreter for whatever we're building. So I think it's interesting to see how that will be linked later on to, or if it will be linked at all, right, with the ability to reflect on the program running to build some interesting IDE tooling, because the runtime will most definitely, right, include an interpreter of the language that we're building. So that interpreter might as well be the same one that we're using for macro expansion, right? First, so that we keep things small, but also so that we keep both sides powerful. And I think that there is some examples here. Yeah, so this is sort of the OCaml that Caramel got translated into, right? After macro expansion. And this is the core Erlang it got translated into. Cool. So yeah, we'll have to define first a little bit of this language, and it might make sense to start by defining the little language and just going straight for a tiny interpreter, right? So we can write a little bit of Q and execute it, right? And then reuse that interpreter to evaluate Q at compile time. I think that'll be fun too. Okay, let's just do that. So we'll add support for multiple clauses, pattern matching, right? And if we've got time, yeah, we've got 2 solid hours. We're gonna begin definition. We expect a lot of errors there. That's fine. So now we go here and we're gonna say we have a bunch of clauses, which is fine. And I guess as long as there's a token that we can read, we're gonna try to read it. And as long as that token is a semicolon, then we will continue, right? So the first thing we do is we say, all right, I'm gonna try to read the clause, right? And we're just gonna push that into clauses. Now, if the next token that we read is not a semicolon, then we're done. We're like breaking out of this thing, right? So some token semicolon, right? Lecture.peak. Yeah, I guess we should say if it is a semicolon, we're just gonna continue, else we'll break. And I'll say that. And this is not doesn't exist, so we will actually create this first. So let's go to token and just add a semicolon here. We're actually going to fix this to include more than one. So function definition. Cool. So instead of none, we should get semicolon now, right? In this little test, and that'll fail, saying that we're missing this stuff over here. Yep, parse left, right, embrace. Perfect. So that should pass that test. There we go. Function definition in the token module. It's there. Next up, we want to parse. What do we want to parse? We want to figure out why this is broken. Okay. So the tokens are good. Brace left, literal string Joe, brace right, semicolon, right? Oh, we're picking everything here? How come? Okay. This is not very legible. Okay. The expected value, right? Oh yeah, of course. Hello world. And that makes sense because when we picked, we didn't actually consume that, right? So we're gonna do lecture the next, right? I'm just gonna drop that token. Ooh. And that's much better. We don't have that error. We have other errors. Cool. I'm gonna go back to our test. And our test was called multiple clauses. much better. Now we see on the left we have a value declaration, right? That's a function that has a number of clauses, and each clause is defined here. So we actually have all the clauses. Perfect. So we're just gonna grab this thing here because they should be pretty much the same. And if we save that and run it, unfortunately diffing is not great off the bat, but we will be able to see some patterns, right? It's getting closer and closer. So we just need to replace the right strings here. And I'm using Joe, Robert, and Mike, which are the founders and creators of Erlang. Perfect. Habemos multiple function clauses. Great. So next up we'll have to add support for pattern matching. This ain't going to be amazing, but it will be something. So we want to do two things here, right? We will want to be able to define very easily, like any, something that we ignore. So for example, underscore, right? So we don't care about that. We will want to have a literal there. So this tells me that we probably want to move this literal into a literal type, right? I don't know if the literal pattern is going to be exactly the same as the literal expression yet. Maybe will. And we will want to have like a variable binding, so bind. And here we will want to have an ID. Yeah, okay, so there's definitely are not going to be the same because the literal expression and literal pattern, because we may want to say, okay, here's a literal list, right? But in the pattern, we want to deconstruct the head and the tail, right? And the head, we want it to be named, so we want it to be like hello, like a variable. And the tail, we want it to be another list, right? That has, well, maybe this is not a good idea. This example, not a good idea. Because if we wanted to say we'll have two more things, right, like 2 and 3, then we can just do that there. We can just say that, right? But I guess the point is that this is a literal pattern, right? And this here is another pattern. And these are also literals that are being used in the pattern. So maybe a literal pattern will have a separate enum than literal expression. So we can say, hey, here's an enum, right? That is a pattern, and we have a list that we want to pattern match on, and the different things in there may also be patterns, right? Like different lists or variable bindings, or ignore the second element, but a third has to be literal, and that literal will actually be just a literal value, right? Yeah. So, oh no, wait. We can just list here, right? And here we would, yeah, I think that makes a lot more sense. And then the list will actually have like a head and a tail, or a number of elements. And those elements will actually be patterns themselves, right? But the literal will always be a literal, like a primitive value. I wonder what distinction do we do for caramel here? Parser, literal, actually parse3. Yeah, we got a pattern. Yes, and literals are actually the same in both. Integer, strings, atoms. So we're using literal for actual primitives rather than any sort of literal value. Okay. So at the very least, we want to have these two. We can start with those, make sure that works, and then we can add more patterns as we go along. Cool. Actually, maybe let me save and commit this right now. before we move any further. Cargo build, cargo test. Is everything else working? Nope. Look at that, broken things. Never mind, false alarm. Okay, so what have we done here? We've added support for function calls and function definitions with multiple clauses. Fit. Actually, what are we using here? Yeah, fit. Support function calls and defining functions with multiple clauses. Cool. Repo slowly getting updated. Yes. Here's a link to the code, by the way, if you want to play along with it. Amazing. So let's go forward. We're gonna do any and bind right now. Actually, let's just do bind first. We can add more later. It's gonna be okay. And we're gonna come to this function at the very bottom, and we're gonna say arg. And we're gonna run the test. It's gonna be broken. Actually, I think we should get rid of the debugs in here for now. We're not gonna need that right now. Cool. Yeah, so now we just need to go into the function clause parsing and say, yeah, let's actually parse arguments, function arguments. And we are probably going to move some of these things in there, like those, right? So when we're parsing function arguments, we're actually expecting to find first parentheses left and then right, and then in the middle we will have a series of patterns, right, that we want to match on, and this will be very close to what we had here, right? I think. So we will have to sort of loop around and say, okay, as long as we haven't found a close parenthesis, right, we can assume that there will still be things to parse, and between each one of the things we would expect a comma to exist, right? So in other words, I think at some point actually, I think we can just borrow this whole thing, right? Which is very, very close. Okay, so we have a pattern, one of those, and we'll do parse pattern, right? We get a pattern, and then we just push it into patterns. Maybe later we'll find a nice way of saying, okay, there is sort of a way of abstracting this loop away. But right now, I think it's fine for us to just use it. So we get a pattern, and that means that we're done with that. The next token is either a comma, which means we're going to add a new pattern, right? Or a a parenthesis, right? A closing parenthesis. And if it is a closing parenthesis, then we are done. We can exit the loop, right? So if it's a comma, we drop the comma, we restart, right? If it's not, if instead we have like parens right, then we'll just break. that will be the same as not having that, because we will still break in any case. Okay, you win. Okay, we're gonna come here and actually return a pattern, and no, we need multiple patterns, so we actually need to return the patterns. So result of back a pattern or parse error. Save. Now we need to actually define our function for parsing the patterns. Go for it. No, why don't you infer the right type? What are you doing to me? And here we will do a very similar thing that we're using for parse expression, where we're saying, okay, I'm gonna pick the first token, right? Where are we? There you go. I'm gonna pick up the token that we're currently at, and based on that token, I'm gonna decide what kind of pattern we're about to read. So if we find an ID, then we know this will be an actual variable binding, right? That's what patterns will be like in this language. So if you have, a function that says a, for example, right? Then this a becomes a variable that is bound to a value. So it will be a pattern that is a binding. So here we'll say, okay, pattern bind, and then we can just almost transfer that over. I think. Can we? How do we do the parse ID before? I think we're just gonna call parse ID. I don't think all of the pattern IDs will be the exact same as all of the expression IDs, but we can start with this and we'll see where it takes us. Cool, that's that. If we have a literal token, like a literal string, then we'll say actually this is the only one we have right now. So we will just forget about everything else. That would be that. When we're trying to parse a pattern inside of the function arguments, right? We're gonna say, if you give me an ID, then I will parse that as an ID and I will return a pattern that is a binding. If you give me any other token, then I don't know what that is. I don't care what that is. We're gonna bring back an error saying I was actually expecting a pattern, but instead I found that thing. So if we go into error, we have expected expression, expected pattern, a pattern. Cool. I think that would be fine. What would not be fine is this little function over here that we had to generate because, or rather write out instead of derive, because Miet does not provide us with partial equality for name sources. Okay. So expect the pattern. It should be pretty much the same thing though. Test. Tell me. Woof. Scary. This is not telling me much. These errors are pretty horrid. So this is failing. Is it failing because we're expecting? Right, we are expecting a pattern there, not anything, like not nothing. So when we do parse function arguments, right? We are saying, okay, just find me the pattern, right? Whereas maybe we want to just say, if we find the parentheses from the get-go, then we just break the loop. If you don't have a parenthesis, then we'll expect a pattern. If we expected a pattern, then we're going to expect a comma to continue parsing, right? And then actually, I think I like this better because it will support this, but it will also support this, and it will also support this, and it will also support this. So trailing commas. Right, let's see. If let some token parents right is lecture pick. So if when we pick the lecture, we actually have parentheses right, we'll just break out of that. So this should cover the case of no arguments whatsoever, right? Which means there is no patterns to this function. But it should also cover the case where we do have some pattern, right? For the save, multiple patterns because we found a comma, and trailing commas before the parentheses. Okay. Test. Huh? That worked. Don't you love it when that happens? Something makes sense, and then, I mean, I'm pretty sure the tests are broken somehow. Because I am legit surprised that it did work. How do you, Blaine, I don't know if you're still listening, but how do you folks solve this in Grain? Do you do trailing commas? I guess you let Manir figure it out. So here, I am going to say, oh yeah, sorry. Trailing commas, yes. I guess you're letting Manir figure out how to handle trailing commas in certain expressions, like function arguments, for example. Yeah. Cool. Gotcha. Yeah, so in here, the token, there will be a token for a comma, right? So we have the same. And then in the parser, depending on what we're parsing, we're sort of special casing for that in some way. Right, yeah. So we allow optional trailing on some expressions. I'm confused. I would expect the arguments to actually show up somewhere. They're not showing up. See, I knew the tests were not telling me the right thing. So this looks okay, but it is not, because we're not actually showing the arguments, right? The patterns for the arguments of the function clause. Why is that? And that is because we're not using this thing. We're just, yeah, yikes. So now things should fail and it should be more interesting. There we go. Parse module with a function call. We have a function clause that has arguments, and the first argument is a binding of whatever you're giving it as the first argument to a variable of ID argument. And I like that. That sounds great. So we want a pattern, bind, and then we want an ID. that. So I think that test will pass now. It did. And now we'll have a very similar thing for the other ones. Now, I'm not suggesting that this is a valid function, right? But it should parse fine. Then we can have a second sort of layer of analysis where we're saying, hey, if you define a function and you're defining it with pattern matching, then it needs to have the same number of arguments. I haven't made up my mind about that yet. I do think that there is some usefulness to being able to not include certain arguments sometimes, right? So this is something that Elixir has tried to add by saying, oh, instead of saying just A and then B, then we'll just say B and the default value will be this much. So if you end up your call with only the first parameter, right, then we will sort of put in the second one for you. I think that is powerful. It has certain uses. Just don't know exactly if I like it that much. And this would be B, and I expect the last one to be exactly the same. Cool. Save, build. Excellent. Okay, so we have a very rudimentary support for pattern matching using only bindings. And I think at this point is where I would start wanting this test to not be actual code like this, but rather to be something that I put through the compiler, right? And get something out like an ASD dump, for example, that is just a big data structure we can compare. Text to text, right? I probably need to say to parser so that it's very obvious that we are parse the smallest set of constructs that make Q-lang Turing complete, and so on. Feed support parsing, finding patterns on function arguments. Okay, I guess we can start beginning the interpreter. We will grab this parse tree for some program, and then we will start evaluating it from some point. Because we can define, for example, a main function, right? And that's the first thing that gets called. Could also define some sort of annotation at the value declaration level, so you can say main, it's going to be my function, right? say q sort of run, right? You have to say what the main file is, right? Like enter point main. Hmm. In any case, we will want to have like an interpreter module. Hmm. We will take a parse tree right now. Program. Definitely not ideal, right? And I guess we will return some form of parse tree that we can render back. We're not gonna really build a REPL with this, right? But right now the only data structure that represents our programs is the parse tree, because we don't have a type tree yet, right? We don't have any other form of representing a program, like smaller lambda representation or SSA. So this we'll have to do right now. What we will have for sure is, instead of error, because we've been using error to define our parse errors, right? I think we would move this into the parser and just say, hey, the parser, I don't know, maybe we can just keep it here as well. Let's just borrow that error. We're going to put an interpreter error here. We don't yet know what this will look like. It will most likely not be a diagnostic, but just an error. We won't need the tokens directly. We will need the parse tree. No buffer either. And I think if we're expecting the parse tree, that means somebody else would have already taken care of parsing the program, right? So what do we need to have an interpreter? We need a program, right, that we're gonna be running. I think maybe this will be not even like that, right? Sorry, like that. And we'll need an environment in which different things like bindings can be saved and recalled. And I think we will also need some form of like lower level functions, right? External functions, right? That those will be defined in the environment, but through the environment they will allow us to access things in the host, right? So for example, if we write a tiny Q program that just does like print hello world, right? Then we would like this print to actually be connected to, for example, a format, right? In Rust. So then we can actually print this out. This is actually something that we, oops, oop. top secret project, not to be talked about yet. Soon though, couple of days. Where are we? Qlang, lam. I remember in lam, I forget the structure of this repo. I think it's live. Yeah, live. We have RTS. We have a couple of runtimes here. One of them was for native, and I mean, calling this runtime is too much. But in here, right, we had the ability to inject different function calls, right, and provide a native implementation for them, so that they will be dispatched whenever the runtime is trying to execute an external function call. So you're saying, okay, if you're trying to call binary split to split binary strings in Erlang, then this will actually be the code that deals with that, right? We would grab everything sort of that's in the arguments, right? And this is not the most, it's probably some of the worst Rust I've written because it was written in such a hurry. But it's just cloning everything and just saying, whatever, let's just grab the thing that we need to split by, right? And check what it is, right? If it's a list, then we'll deal with it in one way or another. If we don't know what it is, or it's not specified here, then we'll just panic and saying, yeah, we cannot call this low-level function, right? And with a second argument that is a non-list or a non-string, right? But if everything goes well, then we actually can grab the elements, right, of the argument that we need to split by, and do this folding where we're actually splitting the first argument, right? It's kind of messy, to be honest. But it was an easy way of saying, well, we need to be able to run some functions right now on the native runtime. Do that. I don't remember if we did something like that for the Wasm runtime. No, I think the Wasm runtime was pretty bare bones. But the ref, was it here? Anyways. So we will want to be able to say, right now, if you call print, right, that is something that we will directly interpret using this Rust code. Like at the end of the day, you have to call some host, right, code to do some things like side effects and whatnot. All right, I'm gonna need a second. I'm gonna go get a fresh can of Coke. I'll be right back. Amazing. Cool. So we got the interpreter, right? We will need an environment. And the environment will pretty much right now, like the fastest we could do here is to say this will be a map, right, of bindings, and the binding will be on the left hand side a name, something that we're trying to access, right? On the right hand side a value, and that value will be something that we can also interpret. So at some point in this little interpreter loop, right, what we're going to do actually, yeah, maybe in run we can sort of set up everything. What we want to do, like self-eval, right, program. We don't really have self here, but yeah, this will be the interpreter, right? And in our eval, we will have access to the environment, but we'll also have a program, right, that we want to deal with. And we would expect this program to actually be a function, so something where we start, right? So program, and then we'll actually expect this specific program. Not even that, I think you cannot evaluate an entire parse tree, you want to evaluate an expression, right? And we will begin by evaluating a function call, right? So here, right, in this sort of match, right, we will go through each one of the different things that we want to evaluate, right, and just write the code that interprets them, that does the thing that they need to do. So if we had in our language the ability to add two numbers together, like plus being a function, right, 1 and 2, to add them together, then here we will get the arguments, right, and the name of the function, and the ID will be plus, and the arguments will be like 1 and 2, right? So what we will do is we will say, okay, I'm gonna grab all the arguments and I'm gonna actually evaluate them first. So I guess args, we can arg expressions. We can go over every argument and just call like self eval, right? And then say, please evaluate this particular argument. And whatever you come back with, we're just gonna push that to the args expression, right? So by the end of that, we will have a bunch of evaluated arguments, right, that we can use to look up the function that corresponds to this ID in the environment, right, and call that. So assuming we have an environment in env, right, we will say lookup ID, because we don't really care what the ID is anymore, right? And we will expect this thing to exist, so we will get a value here. So if the value we get is actually a function, right, and I think we would have, if we look at the parse tree, yeah, it will be function here, an expression function. Then we will get a bunch of clauses, right? And we can ask which clause matches these arguments, right? So this could be eval function, right? And we just pass in the entire thing. Like, wait, I think the iPad died. All right, whatever. So we can pass in the clauses and the arguments, and then this function will figure out whether this set of arguments actually match one of the clauses and pick the body, right? And then we can just evaluate that body, which right now will be a single expression because we haven't allowed our language to define a function that does more than one thing, right? All of the functions we have do one thing right now, which is now very interesting. So this would be our next expression, right? And we just say self eval next. Now, if we have not found the function, so whatever else we found, we will just collapse saying error, interpreter error, right? And here you'll say cannot call non function value. And we can put the ID, we can put the arguments, we can put the whole thing. So we will say this is the thing that we're trying to run. Cool. So results, we will get something back. I don't know yet what, so maybe we'll try to get nothing. But we will definitely have some form of error. Okay, so formatter, do your thing. Environment, we're gonna make you a struct like that. We're gonna have an implementation for you, right? Cool. Hey, Pontus, how's it going, man? Long time no see. Online. Yeah. So I installed this thing called Nightbot. The overall sound, or just the music or the voice? Damn. Overall sound then. Okay. Quickly looking at the audio settings. What? Seriously? When the air conditioning turns on? That low is it? I mean, fine. I can have the microphone closer here. It doesn't really bother me. I mean, just a little bit, but um, interesting because I am using the exact same audio settings that I use for like Zoom calls and things like that. And Apogee is set here in OBS to just, you know, use the audio interface in the exact same way. Advanced audio properties. I do wonder if it has to do with the mono channel some that I have going on. Because the interface is stereo, so if I turn that off, then you will hear me only on the left or only on the right. But yeah, strange. Okay, let me check one last thing. So filters, I do have a filter here. I have a compressor. I don't know where it is. I cannot see it. I'm gonna remove that. Hello, is this better? Oh, yeah, okay. I see my levels here. I've gone way up. Finally, Jesus. So apparently I had a compressor set up on the mic, and that thing was just doing stuff. I don't know. I didn't get to see the actual configuration of the compressor. Hey, hooray! That was a burst of sound. So much better. Yeah, well, amazing. Happy that it works. I assume that the music is still pretty low. Yeah, I was definitely compressing it. Is a music level okay? Like I don't really care that much. I just don't want it to be like super silent. Okay, gotcha. So I'm gonna go for this, which is minus like 19 dB. My visual feedback here is that every time I talk, I'm like 3 times louder than the music is. Cool. But thanks a million for that, because now that means um, other people can also hear me instead of just thinking, why is he streaming in silence? Dope. Now this is good. Now we want to really hear the music when you talk. Excellent. See? Amazing. We've done a great team. I am promoting you both to moderators. What a delight. Cozy. Okay. So from the environment, what we really want to get out, right, is this function called lookup right now. Oh God, what happened? And this should actually be just working on a self. It doesn't really need to mutate the environment itself, or ideally wouldn't. So we'll prevent that. And we will ask for an identifier to be able to get something out of the environment. So either you get something out of that, and this will be an expression, or you will have threatened you. Yeah, you've been banned before, so I'm not sure if you qualify anymore. Pontus, just FYI, if you want to share links, watch out because I have a bot that I cannot control that bans people whenever they are sharing things. I need to talk to someone like Eduardo, RFS, and say, hey man, help me out with this thing. How do you do it? Copy paste settings. Cool. So we're gonna do a pretty dumb thing here. We're just gonna say, yeah, Nightbot Police. We're gonna say the environment is gonna have a couple of bindings inside, and we're just gonna use a hash map, so we can just go into the hash map and just get something out of there. So bindings, get ID, clone. Actually, I think, what was the signature of get? I think it will be an option, right? These things sometimes work so good and sometimes it does not. This is why I hate all of this kind of tooling. See, it doesn't give a damn. So we're just gonna do an if let here. If we get some binding here, right? And this will be like expression. Then we'll just say okay, expression, and we're gonna clone that. Right now, I do not care. If we don't have that, then we'll just say error, and we'll say symbol not found, or undefined symbol, right? And we'll put the ID there, and we'll just say the symbol ID has not been defined in the environment. Cool. So interpreter error. How do you say error? It sounds like rar rar rar. It's so much easier in Spanish. Error with the rolling R. I never got used to that. Okay. Cool. So now we have a lookup function that goes into the environment and just does the right thing. Let's import this map. That should be good as well. Save. What are you complaining about? Expected expression? The method get exists for structure. Okay, I'm gonna import a token there. No, don't do that. Oh my god. I hate it when it does that. What is the trade that we need? Let's do cargo test, see what happens. I really wonder if that was the reason some people were joining, right? And then just leaving. It's like, oh, look at that. There's code on the screen. Cool. Okay, so to be able to use get, we'll actually need to have a hash. That makes perfect sense. So going here, we're going to derive hash. And we'll need equality as well. Cool. Cool. Going back to the interpreter. we will need to define this thing, right? Where the ID is an ID, and arguments is, what are the arguments? Expressions. So vector of expression. Okay. We actually, I think a better error than this will be just to say ID is this other kind of type. Or we expected ID to be a function, but instead found whatever that is. Save. What are we missing here? Comma. Really? You're not gonna format? There you go. Dereference clone. Okay, so we need the program there. That's good. We still haven't done the setup. We're just working on the evaluation of this thing, right? We are missing a bunch of arms. That's fine. If we have a lookup and we find a function, we will just return whatever that function evaluates to. That's fine. By passing in I guess we could look that up first and then just go into eval function, right? So create this. And then we evaluate all of that. So this defines how a function is evaluated. This just goes into the environment, finds the function, and says, okay, just evaluate that function. So we will return whatever that is. Cool. So this is starting to look more like something. Parse tree, why are you complaining? Unwrap result type. I'm going to fill this with a bunch of to-dos until it compiles, and then we'll start fixing these ones one at a time. So when we evaluate a function, we want to return right now something, not nothing. So this will definitely not be that. So I think we'll return an expression. So after we have this, we need to find the clause that matches, right? So we can say clause and self find matching clause, and we're going to give you the clauses and the evaluated arguments. Either you give us one or you fail. And if you fail, then right now we're just going to crash. Now that we have that clause, we can actually do the work. Okay, so there's a couple of things that are missing here, and is that the environment needs to work. Like, we'll have to implement a sort of stack, right? to say when you are about to call something, then you go into this new frame where some things may be defined, right? We don't want to have a global environment where any function sort of can modify or add things that will not get cleaned up later on, because then a function that is defined inside, a binding that's defined inside of a function will be available outside of the function, and as much Q that sounds like it sounds like a terrible idea. We don't want to be able to snap our fingers and just have access to any variable within any scope, right? We want order to some degree, order in this world. Okay, so the question here would be, where do we handle, right, this interpretation? So we will have an environment, and maybe the environment is something that will be tied to each individual frame of the stack. Or there will be layers to the environment. So as you go deeper in, you define sub-environments, right? That you can traverse upwards, but you cannot traverse downwards, right? When you say look up something in the environment, it's like, hey, do I have it? Yeah, perfect. Do I not have it? Then does my parent stack environment have it? So if we had something like that, like parent, option, environment, then we'll be able to say, okay, I think we'll need a box there in the middle. Cool. Then we'll be able to say, if I don't have it, right, then just go to my parent and try to look it up. So every time we call a new function, right, then we will push a new environment, right, that will only have that will have for parent the current environment before the function call, and the environment for this particular call will only have bound the things that we have pattern matched against, right? So if you don't pattern match against something, then it does not get bound, and that will be the end of it. At some point, I guess this will evolve into a split environment where some things are defined in the stack, and the stack will behave very close to this, right? And some of the things will be defined on the heap, which will be more of a... No, actually, the heap will just have all sorts of crazy crap in there, but you only will be able to access it through essentially pointers that live on the stack. Oh, it did. 1 second. Feels like we're having all the technical issues this time around. And are we back? I think we're back. Thanks, Dima. Cool. All right, so what should we do? Should we go again ahead with this sort of naive environment approach? Should we try to mimic something from some other language? Do you got any pointers or ideas or thoughts? Dima, I know that you do. So, do you got anything that you like to share? This is the time. Oh, we were just looking at building the tiny interpreter, right, for the little bit of the language that we have defined so far. And in this approach, right, we would sort of define an environment that works like a stack where every time you go into a function call, you just define a new environment, right? And you sort of say, okay, my parent will be the last environment. So you can look upwards, but you cannot look downwards, right? On the chain for the bindings. And then at the end of every function call, then we'll just sort of pop the environment back. So the current environment will become essentially the parent of the environment we just destroyed or just used. Yeah, yeah, exactly. To both of you. So it is like scopes. Um, I don't know how far this will take us, but right now we just want to be able to run a little bit of what we've written, right? To say, yeah, it's alive, it runs. Okay, so we're gonna do just that. Um, we will have an environment here, right? And the environment itself has a parent, which will start with none, and a hash map, right? I think it's default. But we wouldn't be able to say, hey, sort of push a new scope and then pop. So I think the right terminology here would be to just say stack and to call these things frames, right? Parent frame and so on. But okay, so push frame, and this will actually do mute self. We would want to say new frame is going to be environment new, right? Actually, we will want to just construct the environment here. And the parent is going to be us. And the binding is going to be new. Huh. I haven't done this before. Sort of having to replace the ownership of myself with a different data structure that owns me. I don't think this will fly though. I think we will actually have to, yeah, so this will have to be like some, even if it was some, right, then we get a box. Fine, we can box ourselves, that's fine. But then, yeah, and the return pointer will be where in the code you're actually gonna come back to. Right now we don't really have that. Like we're actually just gonna interpret the parse tree because that's as far as we got, right? We got the lexing stage, we got a parser, and we want to run a little bit of that parser, right, with this very naive interpreter, so we can use this later on to do a macro expander. So the macro expander will actually evaluate with the interpreter, which hopefully in the future will be the same interpreter that the runtime is going to use to execute the code, right? So you can use the same language to write the macros and run the code later. Yeah, we're interpreting from the ASD, from the parse tree. Like right now, the only tree we have is the parse tree, the thing that we're reading from the sort of tokens. This is actually noise right now. We'll add them later if we really need it. Okay, so every time we want to evaluate a function, we're going to evaluate all the arguments, right? We're going to find the clause that matches that, right? And then we're going to say self the environment, right? And we want to sort of push a frame. And so then we're in a clean frame. And then after we do the work, we're going to say pop frame, right? So the environment inside between these two lines is like, good, we can buy new things. They will not be available outside, right? Of this function call. And then when we get out by popping the frame, then the function above us, right, has the same environment they had. Nothing has been modified there. Or rather, we haven't leaked bindings between environments. So maybe it will be useful to grab this environment, right, and work with that in isolation just a little bit. Test that, make sure that we can make it work the way we expect it for, like we just have a few behaviors here that we want to guarantee, right? When you want to bind something new, right, it's available within the current stack scope, right, on the subscopes, right, but not available from the upper scope. Let me do that. We're going to move this out into source, environment. And I think I'm just going to move these things out here as well. And we're going to define an environment error. And right now we only want undefined symbol, right? That will be the thing that we want. So if we come back here, we don't have undefined symbol, but we will have a bunch of other code. Okay, so we're not really using this right now. Let's get the environment working the way we expect it to. And we can come back. Yeah, I mean, you're right. Maybe this is too basic to test it. So there's one thing that I want to figure out how to do nicely, which is this push and pop frame, right? Because I would like it to replace the current self with something else. So maybe I need to do something like that, right? I don't know if that is even valid. All right, let's do that. Environment, variable shadowing, right? So we'll get an environment. We will need a function for binding things. And this will take an ID and we'll take an expression. Is that the way you write it like that? Cool. And we'll just do self bindings insert, right? ID, actually I think I need to, there you go. Yep. Semicolon there. Good. Okay, so let's move env. We're gonna make a new environment. And we're gonna say, so rebinding in this case will be allowed, right? That'll be fine. Whoa! Hello, Diogo. Thank you very much. So we'll just bind an ID here, let's say A, right? To an expression. And the expression is gonna be, we can just do literal string here. Hello. And we'll have to do the same here. Cool. Use super, get that down there. All right, we got an environment there. We got the binding. We should be able to look that up and get hello, right? The expression there. So assert equals, and we'll say environment lookup, right? So A. I'm just gonna put that there. So if we look up A, then the output of this should be an expression, right? So we're gonna just unwrap that, and the value should be equals to hello string. Yeah, exactly. I haven't defined any of these things right now. I think maybe it will be single assignment. Shadowing will be nice to test. If anything, just to have a little environment here that we can say, okay, this is how we can expect it to work. Assert matches. So cargo test, environment. Cool, so the interpreter needs the environment. Nope, go away. I don't care about you right now. Move occurs because value of type parse tree expression which does not have the copy trait. I guess this is what you want, right? Yeah, exactly. Which is fine. Just need to make sure that things are clonable in here. Which I think they should, because I own this data. There you go. That's better. So bind, actually, I think they will want the data. You're saying I can probably need to match and value on matches. I don't know, I always have trouble getting the test matches to do the thing that I wanted to do. Like when I do assert, no matches, right? Value on the left, this thing. But then I don't actually have a pattern. So I wanted to match this exact same string rather than just any other literal string, right? So if I was to say, you know, let's say I remove the unwrap and I just do like, okay, expression, literal string, right? I cannot really like type in the string that I want to pattern match against here, right? Or at least in the past, this has been failure. Wait, actually. Yeah, exactly. So that's why I'm using assert equals instead of matches, because I want to pattern match on that, right? On that string directly. and it's saying, no, you cannot do that. I guess maybe the problem is that I need to do a reference to the string. No, sorry. This is type mismatch type expected struct string. I see your point. I do see your point. I would have to actually pattern match on the string. Yeah. Yeah, exactly. Esther if string equals hello. So expression literal string. Yes. So I see the value of this, and I can see how it can help me make some of these pattern matches clearer. But I am not a fan of it. Because I would like to be able to use the exact same value rather than have to duplicate some of these things in the test. So in this case, because I already have the hello string, but I cannot reuse it in here, right? Then I'm forced to first sort of rethink how I am going to match the exact same thing. And second, to keep those two in sync, make sure that they are the same. It's just a little bit of maintenance, but you can imagine if you have, I don't know, dozens or thousands of tests like this, you need to keep all of them in place. This may be a spacious argument, so if you disagree, just let me know. You mean like this? Right? So, just to entertain that for a second, how is this any different or even like shorter than just writing this? Like, I get that it's more flexible. I fully see that, right? But to me, this is like much more straight. It's like I have this thing, I just need to unwrap the lookup and compare those two things directly. If this is going to generate also a better diff, then I am all for it, right? But right now, I don't think it will. I think it's just gonna tell me the same thing as if this thing fails, right? Like for example, let's say we always return. Yeah, okay, I see your point. So I don't have to I don't have to be as specific with how I am getting to the data that's the actual pieces of data that contain information I want to assert on. All right, so this is the failed assertion, right? I just get a failed assertion saying, nope, this match failed, right? And if I use the other one, the one I had before, I need to clone, sorry. Yeah, so in this one, I actually see the error because I'm calling, unwrap. If I wasn't, which maybe makes things a little more even. And I can't do that, can I? No, because I need to do partial equality. Right. Okay, let's have a look at how the matches work here. Rust matches. We have some patterns. We have it in the guards. Am I missing something here? I don't actually see that other argument. I see the expression. And then we have sort of all the patterns with the guards. All right, let's see what Cold News has to say. Knoldus? Yeah. All right, so that's the thing we were looking at. Doesn't say much more. What do you mean by use extra arguments to assert macro and format the bad value? Oh, okay, now I see what you mean. Never mind. Never mind, that's on me. Yes, so these have all the arguments here that we can pass in. Yeah, exactly. I see that. Right. So now you're asking, but like, do you see what I mean? Like, now I have to also say like, let's say A, right? And B, or even if it's just A. What the hell are we doing here? I also need to pass those in, right? And in this case, let's say this will be like B, right? Actually, B and then expression. No, I just want the expression, really. Will this actually bind expression out of the match? Yeah, exactly. B, hello string. B, hello string. All right, so I just want to be obvious here, right? I could write all this stuff. I could. And maybe I can make a macro on top of this stuff that does it for me, right? But from where I'm standing, writing assert EQ and just saying I'm gonna unwrap all of the errors or okays because I know I don't expect them to happen in this particular test, and just trying to compare two things directly, right? Seems to be so far doing better bang for buck. Oh, sorry. B, what's the problem here? Oh, we need clone? Yes. And I don't know if I'm going to be able to clone this error. I think I will. Maybe not. B, this error result cannot be actually formatted with the default formatter. Let's see if we use the debug formatter there. Okay, just gonna comment that out. Expression is partially moved there. So I understand the flexibility that this would give me if I had a lot of sort of things that need to be considered, right, in this particular match. That would make a lot of sense. Just sit down. Yeah, sure. We can match on the B there. That's fine. I'm just trying to get the test to fail to see the output. So can you give me one reason why you would not use assert EQ that will give you pretty much the same sort of error? Of course, it's not going to be customizable in the same way, right? But it will say, hey, you called unwrap and you sort of got this undefined symbol. I don't get to see the hello string, that's fine, but also this is clearly not passing even the basic assertion. I'm just trying to understand if there's something that I'm missing, right, on using assert EQ here, that's all. We're sort of evaluating the differences between just calling assert EQ, right, on two values that I want to compare through like a derived partial EQ trait, right? Yeah, okay, I definitely see your point. Yeah, if you wanted to do like an AST match, then matches makes perfect sense because you otherwise have like a rather large, right, type, and you will want to derive that. You will want to generate that entire match expression. Okay. But even then, if you know exactly what you want, yeah. So yeah, Blaine, what we were looking at is like when do we use assert EQ versus when would you use something like assert matches? Yeah, exactly. More macros. I don't know. Yeah, yeah, I see your point. Okay, we'll see how it goes. Right now, I don't actually need that because I already have the exact value that I want. But as we move on more complex things, it might be useful to use assert matches, right? And actually passing. Oh shit! I lost the implementation of lookup. God damn it! Yes, for my one test, EQ is fine. Thank you, thank you. So I'm gonna roll back until I get that. So I don't want to write it again. There you go. Okay, so that works fine there. Now we want to actually push a frame, right? And redefine A with a different value, and then make sure that when we look it up, we get that value. So we're gonna do pretty much the same thing here, right? But we expect to find like or first string, right, and then second string. And I would like to see this fail first. So here we're gonna say push frame. And first string. Yes, so this is the thing that I am fearing. So I might actually need to have a different data structure around the environment to be able to swap, right, the environment around more easily. How would you do this, Dima? Would you actually try to swap the contents of self, right, by a different instance of the same data structure? Because it would be pretty straightforward to just like wrap this up, or have something called scope, right? I think I'll do that. And then we'll just have a current scope, right? And I would like to move this out. Right. Oh, yeah. So when we push a frame, the current becomes a parent, right? And then the current moves to the parent, and the current becomes a new scope. And then when you pop, then we just essentially drop the current, right? And move the parent. No, the problem here is that we only have one at a time, and that's not what we want to do. So I think instead of having an option, we're just gonna have a vector. I'm just gonna push and pop from that, and that will be a lot easier to work with as well, because we'll just keep pushing into, right, and then we're popping out of, instead of doing this stuff. Actually, we don't even need to do that. We just need to say scopes. Boom. There you go. So scopes is empty vector first, right? And then when you want to push something, yeah, that might be useful. I think that will be useful for the lookup, right? Because if there's something is not on the current like top of the vector, then we want to start traversing it backwards, right? Until we find the thing that we want. So if we didn't have a vector, if we instead had like a bunch of scopes that are linked together, then that would be interesting. I think it'll make it easier to just reparent scopes if we need to. Weak references. So a push a frame will be scopes push, right? And then we're just gonna push a new frame here. So a bunch of people watching. Hello folks, how's it going? We're building a programming language here, or trying to at least. You can find more about it on a tweet that we have over here. And also in a tiny little repo in Abstract Machines Lab QLang. Yeah, I'll drop a link on the chat so you can have a look if you want to follow along. Cool. So if we want to push a frame, we just push a new scope. I guess maybe at some point we'll just call it a frame. So push scope. I'll just call it push scope and pop scope. And when we want to pop a scope, then we just go scopes pop, and then we just get rid of that, right? Perfect. Binding. Binding means we have to go to the current scope, right? And do something with that. So we should always have at least one scope. That ought to do it. Okay, so now we want to check the top of the stack, right? And in there we'll just deal with the bindings insert. So scopes, and let's see, what do we have here? Last mutable. Sounds very nice. Almost exactly what we want, right? And I will expect to always have something there. Excellent. And we'll do last, I think. Oh, sorry, scopes. Split, I would like a pointer to the last one, please, without an immutable pointer to the last. Nope, align, fail. There you go, last. Cool. So we'll get the last, and this will really be the current. So maybe we can just say function current scope, right? No, never mind. We'll take care of that in a second. If it's not in there last, then we need to start traversing this backwards. So for scope in self.scopes iter, and I think we will want to do a reverse here. Yes. And skip one, because we already took the last one. We are going to just ask, and I think now it will make more sense to move some of this logic into the scope itself. Hello Jixer, how's it going? I always thought about new programming languages as from scratch, but using Rust here, what do you mean? Would you write your new programming language in what? Butterfly flaps? Or buckets of sand? Like, what would you write it in? Yeah, I think Dima, the thing I don't like about using a vector scopes is that the approach of having linked scopes, the link to the parent, is pretty clean, right? Like you're just saying, hey, I don't have this thing. Parent, do you have it? Yeah, like I think most languages build on another language first, and once they have a version of themselves that can be used to write the compiler itself in the language, right? Then they can bootstrap. Like Rust actually, I think Rust bootstrapped from OCaml, right? Like the original versions of Rust were written in it, and then at some point the bootstrapping, yeah, yeah, exactly. Rust was built in OCaml before it self-hosted. So when we're popping a scope, we're just saying the parent of my current scope becomes the current scope. So if let's scope parent, right? Then self dot current scope equals scope, right? Else we'll just say current scope equals derived default. It moves around. So when we're binding something, we're just saying current scope bindings. I have a stack underflow error. You sure with that? If there's no parent scope, right? Then you just go into an empty scope. I don't know how desirable this would be. Maybe this is like an error, right? Nope, there's no parent of this scope. Just blow up. You're calling pop too much, right? Oh, absolutely no worries, Kickstarter. Like, we're all good. I mean, sure. I think we can, yeah, I can also just let it crash nicely, right? And say, well, whatever you have here, we're gonna unwrap, right? And then this will be a nice little panic there. Definitely some things can be done better. but it's really in the lookup where I think it makes sense to consider that edge case and deal with that with like a proper error. Pope. Exactly, tactical panicking. Yeah. Yeah, so here we're just going to say if there's no parent, right? Or if there is some parent, then we'll just return the parent dot right. So I'm going to move the lookup to an implementation on scope. Because then I have myself, right? I have myself, and that means I know how to look more things up. And if it's not defined in the scope, in the chain of scopes, that's fine. So the environment just deals with like pushing and popping scopes, right? And it will have a function for looking things up on the current scope, right? But it won't know how to actually traverse the scopes. So I think I am more comfortable with that. So parent lookup ID, like that. Cool. So that seems to be there. So now I can just say self current scope, right? Lookup ID. Borrowing the contents. I think I want to actually dereference the contents there. I could just use stake. And then dereference that box. Cannot be dereferenced? What is this madness? Expected a semicolon. Wait. You win. I'm gonna just say cannot pop. I guess this will be a stack underflow. God damn it. It's not really just a stack underflow, but like could not pop current scope. Scope underflow? Okay, you will have to do with that. Scope underflow. Attempted to pop one scope too many. Thank you very much. Are you making burgers still? Push frame, that's fine. Push scope. What I didn't want to do is clone the parent, right? I just want to move the parent out of the child, of the current scope, so I can do that parent take. Oof, that sounds great. This is complaining, but I don't actually see the error there. Oh, Jesus. Was that the problem, really, all along? I should have just boxed that thing. Some box new parent. Excuse me? No. So I consume the current scope parent, and I get the parent there, right? So I should be able to just say parent here, because this is a scope, and that's what we're trying to assign. But this will be a box, right? So if we do that, then it should be like, oh, box of environment. Didn't we have this before? And now this is saying that I need to borrow. I guess it's because it doesn't implement copy. Yeah, that's fine. Like, we don't want that to be copied. We want to move. Yeah, I hear you. Because the moment I borrow this thing, then oh my god, I need to dereference twice. Would that be it? Nope, that's not gonna work, because I already have a borrow on the thing. Fine, fine, I will use an arc. Import. Cool. So instead of box, we're gonna do arc new. I guess what's bothering me here is that when we do the current scope parent, right? Right. So we actually need to just work with the scoping here a little bit. Because the borrow happens within here, but outside the self.current scope is not borrowed anymore, right? And once that borrow is gone, then I have access to the parent. Actually, I think the borrow will outlive the scope because of what we're... No, it wouldn't, because now it's an arc, right? And the arc will just get copied. Exactly, yeah. When I do that, I am both trying to move and use it. Okay, let's do that. But I don't think now I need that though, because if I'm getting the arc out, right, by just cloning it, then this thing here, the parent, should no longer hold a reference to self.current scope. Yeah, and that makes sense. The only problem here is that now I have an arc, and I need to sort of dereference that. I don't think this will actually work. No, I can't really move out. So my original strategy was gonna be like, all right, we're gonna borrow from current scope parent if there is something. If there is nothing, we're just gonna return an empty scope. So then this thing, right, will just generate a new value. Yeah, if I wanted the arc to let me modify the value, I guess I would need a. What did I use before in LAM? An arc read write lock for that. So then the arc gives you the read write log, and from the read write log you get an actual writable, mutable pointer. Oof. My brain is fried. So what I like with using the box is that I'm just saying point to some memory somewhere, right? And that will be the end of it. This naive code is not going to work because we have the borrow, right, happening right now here. Which means this thing, right, just having that parent around means we cannot really reassign self.current scope. Excellent question. Not really. I think it's just a good way of playing around with building some of these things. It will tie with the startup soon, but I haven't told you what it really is about, so I can't tell you how. Soon though, more on that soon. How have I done this before? Because I remember, I think I've used take before. Something like this. Right? Of course, take is gonna blow up if something goes wrong there. But I think I remember using something like take for this. For saying, I'm gonna grab something from within the data structure, right? I'm just gonna take the ownership of it, right? And then move it around. Oh, actually, take is an option. Huh. Let me go back. I already had all this stuff there. Because what's bothering me here is that while accessing the parent, I cannot really modify the current, right? Ooh. So let's say I get rid of uarc. If we go back to box. Perfect. And that worked. I think that's what I wanted to do. We'll see. this is not gonna work. So we have a very similar problem the other way around, right? So when we're popping, because the parent may be none, we can use take, which sort of transfers ownership, which is nice. But because the current scope is always there, it's partially there. Now it's on the pushing, right? When we have to grab the current scope and sort of wrap it around something else. So I would like to move the value of the current scope from the environment into another variable. So then I can wrap it and then use a new value, right? As a new current scope. I guess if I had a lambda, I would do move, but I don't actually know if that would move the entire self. Yeah, no, but I think it makes sense because we're saying we want to move this thing, but we don't want to move self. I guess the problem is that while this is moved, you can't really modify this, right? Really, the quick way out of this will just be to clone it. Say, okay, we're just gonna clone the environment and wrap it, and off we go. We don't have clone yet, but sure. See, like that borrow check's fine. Excellent. It fails on everything, which is what we wanted. And that passes. So the behavior is there. The thing is, how do we avoid doing that clone? Note, or actually to do, how can we avoid doing this clone? I will love that because if the scope gets big, then this will be expensive. But Dima, I have the good question there for you then. So when you're back from cooking, then you can help me figure out how the hell do we grab that, wrap it, right, and assign it right where it was. My guess is that there's some lower level primitives for handling sort of dropping parts of a struct that I'm not familiar with. Yes, let's see, let's push some of this code. And we're gonna do, what do we do? Feet, begin sketching, or sketch environment for interpreter. Bum, 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 bum. Code is here. Amazing. Yay. We're gonna add also to the captain's log. Begin an interpreter. I guess we did like sketch an environment with support for nested lexical scoping. So now we can do something like lookups, right? Environment, test lookup, or can look up on parent scope. Yeah, I hear you. For the most part, I feel like and this has been my approach to other pieces of Rust in other places, right? Just clone everything, right? Unless you know that this is going to be big, like, oh, I have read multiple files, right? could be megabytes worth of data. I'm gonna try not to clone that, right? But otherwise, just clone stuff and profile. At some point, that may be the problem, but may not be. Maybe there are other things that are, bigger bottlenecks, performance bottlenecks, depending on what you're doing, right? Because really, like now that I have the interface and I have a couple of tests saying, hey, this is how it behaves. If this is really the bottleneck, I can sit down and optimize the crap out of it, right? So that we actually never duplicate a single bit. We're just reusing everything the way it needs to be. But since this is not um, this is not an exercise in shipping this environment code, right? As fast as we can, but rather like, all right, we'll play around with this. We'll learn some Rust. We do some Rust, right? In the process, then I'm taking some liberties. Like, okay, I'll try to figure out what would be a good way of doing this, right? So we did the first approach, and it didn't quite work. Yeah, exactly. A lot of them won't implement clone, and then you'll be like stuck with it. Um, yes. So then choose libraries that do. uh, Not always possible, right? But it is what it is. Okay, I'm actually out of Coke again. I'm gonna go open a little bottle. Be right back. Um, I got something that works, Dima. And it does the thing that we wanted to do behavior-wise, but it's just I have one little clone, and I'm wondering how can we avoid that, right? So when we're popping the scope, we can just take the parent, right? So transfer ownership out of this struct, right? And that works fine. But when we're pushing, we have the current scope, right? And we would like to wrap this up in a new scope and then push that scope into the same place on the self struct. And here is where we enter and like get into a borrow checker problem, because clearly when you do, assign old scope to current scope, you are borrowing from all current scope. And I would like to have something like take, but I'm afraid I don't actually know what the right function would be to do just that. So for the sake of continuing with the behavior, I cloned it. But if you know exactly how to do that, oh yeah, we're doing that. We have old scope here, right? Is equals self.current scope. Like that, right? I need copy for that, right? So if you can think of the right thing, then happy to come back to this and change it, right? But in the meantime, I will keep testing that we actually can look up on the parent scope, but not in the child scopes, right? So I want to do a push and look up. Okay. That works. Cannot. lookup on child scopes. So the first thing we're going to do is say we're going to push a scope, right? And we're going to define this thing, and then we're going to pop scope. So the lookup here let's see. I expect that to fail, actually. Emp. Cool. That makes sense. Undefined symbol ID. Perfect. Love it. That's good. Cannot look up on child scope. Okay. But what we're gonna do is we are going to make sure that we have bound this thing on a child scope first. So this will be okay, and I have no idea what we're gonna find here. So let's just actually run the test. Excellent. Yeah, so we don't have that, we just have okay, and then we will get an expression, right, actually. Yes, I observed that reason. Can you give me an example of how you would use arc here to actually swap the value by something else? Oh well, there you go. I'm gonna have a second one at hand. Always so scary to open a bottle or anything near electronics, especially if it's like carbonated. You never know when it's going to betray you and explode. This is turning out to be a long stream. 3:38. Damn. I hope I haven't forgotten to get to any meetings in the last 3 hours. Okay, so let's run all the tests, see what happens. Cool. All right, everything's there. We're gonna add chore or test and test scoping rules. So you're saying, if we actually rewrite lock behind an RC here, an arc, right? Then when we want to read, I don't see how this will help us. Like, I am clearly not understanding something here. Because instead of cloning, we will say like, okay, I want read log, right? Oh. Yeah. Oh, so you're saying I would be able to get a mutable reference to this thing here. So I'll be able to say, I'm right, I guess. I guess I'll have to pattern match on that to see if the lock actually succeeded, right? So self current scope. No, these are none of the things that I want. Rust, RW lock, rewrite. But I can't have like a consuming mute self. I need a reference because I need to be able to continue using the environment after I push the scope. Okay, but I see your point because I could say self.current scope, right? Read and just unwrap out of that. So this will actually point to the actual location in memory of the current scope, which will not be borrowing from self.current scope, right? And then I can get no, I don't need the writing here. Is this what you're saying? I guess I will have to wrap the new scope. I think I'll try to draw this thing down. So just for my own entertainment here, my own education really, right? We will have an environment, right? And that environment will have a scope inside. What we're trying to say is that when this is a scope directly, it lives inside of the environment, right? Emp. But when this is an arc, right? Then this actually is just pointing somewhere on the heap, right? For a piece of memory that is my scope. So, scope. Right? Let me just remove that. And because we have a mutable reference to this, to the environment, so we have an ampersand mute, right? Mute. Then self dot current scope. Oui. It's just the little bit of memory, right, that points to my actual scope. So I should be able to change this, right? To reassign it to a new box, right? To a new arc with a new lock that points to a new scope. I'm forgetting how to write with this thing. Maybe I never knew how to write. Scope 2, right? And by getting a read lock before I do that, then I should be able to find out where this is to make sure the scope of here points to this one. Is that what you're saying, Dima? And I just realized that you can't see the entire drawing. Oops. Gonna put this front and center. There you go. Yeah, I know. There's such a delay over this thing. Even like I'm running it on like a low latency mode, and there's still like I don't know, 30 seconds to a minute, maybe more. Okay, but this sounds like a nifty little recipe to have, right? When working with data that has to change itself, or that has to be reparented without losing a reference to it. Like I can see how we would need something like this for doing some AST rewrites, right? Like you want to reparent the node in the AST, you have to go ahead and do sort of this little dance. So let's see what we can do about it. Ooh, so much stuff. Yeah, exactly. I think if that's the case, then this will work fine. So we just need to do arc new, right? And then lock new, right? And just import that. And import it lock. Save. We're gonna have some errors somewhere else. We get a guard here from reading. Okay. Well, I can leave with a single clone for now then. I will put a stop to this madness and we will move on. All right. I do feel like we should get back to this at some point. I would like to start collecting some of these tiny little patterns so that I can just keep it in my hand and say, oh, this is sort of what I'm trying to do with the data. Cool. Then this pattern helps me and so on. All right, so we have an environment now. We can push and pop scopes, right? We can define bindings, and once you do, you can look them up, right? And as you go down in scopes, right, nested scopes, you can access your parent scopes, right? But you cannot really access from a parent to a child. I think that's fine. So you sort of inherit, right? But not give back to your parents. And shadowing works. We have shadowing there, that's fine. If you want to change that, great. We have a test to do that. Cool. There's a couple of errors here, like the scope underflow. We no longer have, we have that. What the hell? Oh, I guess most of these are marked as never used because we're not really using them in our interpreter. So we can go back to the interpreter and try to get something to evaluate, right? Yeah. So this is gonna be push scope. Actually, yeah, would it? Yeah, it would. It would. Push scope, right, and then pop scope. And we have to map error and just say like interpreter error, environment error, and we're just gonna use this error. Yes, more macros, right, to just transparently move or wrap, right, the environment error from the environment error type. Error environment. Cool. Sorry, error transparent. God damn it. Cool. So we don't yet have this function here, but at least the environment push and pop are safe, and we can rely on that just fine. We're gonna write a couple of tests for this thing as well. I don't know how much of a setup we will need. Okay, so expression, that's what we want to evaluate, right? And we have an environment, but we also need to sort of load a program first so that we build up the environment by defining some things that will be available at the top level. So if your program begins with saying print hello world, right, like this, then you want to say, all right, my environment is going to be a map, and there will be like the ID print, and this will map to these functions, right? So then whenever somebody tries to call print, we actually can find something, right, for it to run. Otherwise, we will be done. There will be not much to do. So maybe we can just say new even, right? And you have to give us a program, and then we'll just give you an interpreter. And we'll hold that program very dearly. We will initialize an environment from that program. Yeah, we can do program. How to do this nicely? Environment, new, and I guess we want to pre-fill. Yeah, okay, I'll just do that there. We'll get a new environment, right? And then we're gonna traverse our program to sort of mutate that environment to add all the bindings. I think that'll be fine. The parse tree actually is defined as a module. It has a bunch of items. Each item is a module item type, right? Which right now is just a mod value declaration. And this is pretty nice because this is literally what we just wanna push into the environment. Yeah, I actually have Clippy already, I think. I do, yeah. Here, it's complaining about a bunch of things. I just haven't run it in a while in this project, which is also pretty small. Yeah. I think once we have something that more or less starts running, right, with this very small language, then we'll start looking into, okay, how can we actually write the Rust that does like the sort of more idiomatically, right, achieve the same thing. Cool. So for a value declaration in a program.items, right? I think we can even just go ahead and do item, module item. Is there a for let? Parse module item. Don't think so. I think I'll just have to do the if let inside. Just, yeah, oh my god, are you kidding me? If let item, right? Then we will just push that item into the environment, which is great. So we'll do env bind and we'll say vd.id, and ideally we will be able to do that, right? But I think we'll have to clone here because we need to own those things. vd.vexpr. Huh, we don't have the parse tree? We should. I keep making this mistake. It's not called parse tree, it's called module. So this is a very limited interpreter. It can only run one module at a time, folks. Name and value. There we go. Cool. So that would mean our environment actually has everything we need when we load it, right? We can just start executing things. Holy, this is pretty ugly indentation. Don't give me that. Really? That's what you're gonna go for? Okay. So we first load everything into the environment, and then we have a function that we can call. So I would like at some point to be able to say interpreter eval, right, and then pass in a function call, so like main, for example, so that the program kickstarts, like starts running. So this will be like our entry point. Okay, that's there. Cool. Cool. Okay. Yeah. So after we've evaluated all the arguments, right? And we found the clause. We want to go through that clause, right? And grab all the patterns and bind by finding all of the patterns that have an ID somewhere. So right now our pattern matching is not very smart, right? The only thing we can do is pattern match to an entire variable. I would really like to get something running before we finish. Okay, so to do that, we are just gonna grab the first one of the clauses because right now, no, that's terrible. Why would we do that? Screw it. Let's define find match clauses. We will get a vector of expressions here, right? And then we will result back in either a single fun clause that we want to run, right? Or an interpreter error. So for clause in clauses, right? We're going to go through each one of them and we're going to ask. First, does the clause have the same number of arguments as the arguments expression? I think that could rule it out. So if clause args_len, right, is not the same as the args expression len, right, then we'll just skip this one, continue. If they do have it, right, then now we want to sort of zip it. You mean... no, I'm actually consuming the clauses here, right? Like I've moved all the clauses into this function right now already. I think that should be safe. I mean, it should be okay. So now we want to zip all the patterns, right, with all the arguments. So clause args iter, and I don't even know if there is a zip that we can just rely on. Zip, there is. Amazing. And we're gonna do args expressions, right? That iter, and now we'll have a zip version of like both things. So I think we want to do actually that inside there. We might not even need to do that, return the actual clause, but rather bind matching clause. For pattern value, right, in this thing, and a node self, this will not work with actual patterns. But now we can do self and the bind and say if the pattern is a bind, right, we'll get an ID. If it's not, on the else side here to do, deconstruct the value using the pattern. And then after that, we can do self, eval, actually bind matching clause. So we actually can return the expression. Fine, we'll just call self eval clause, and I think it's called body, and then we'll break. It's called body. Yeah. Oof. This feels super hacky. Definitely not the way I want to sit down and write it, but I would like to get something that runs right now so we can work on that in the next stream and improve it. Okay, so what I don't like about this is that we would not be returning whatever the evaluation comes back to, right? So I think maybe it makes more sense to just say we'll return that, right? In reality, what we would really want to do here is make sure, or to do, right? Make sure the entire pattern matches all the arguments, right? And only then bind, right? Because otherwise, if we bind a couple of things, in this case, we will sort of find the first one of the clauses, right, that has the same number of arguments, and just bind whatever we can, which is terrible. That's not how this should work. So if we cannot find matches to all the patterns, then we will not execute that body, and we will just continue to the next clause. And eventually we'll run out of clauses and say, return error, interpreter error, unmatched clause. I forget what's the, yeah, okay, so clause match error. Saying we cannot find a clause that matches this particular set of arguments. And here we can include like all the clauses and all the arguments, so it's easy to debug or not. Clause. We could not find a clause that matches these arguments. Oh, so this is a function call. This is we are here, right, evaluating an expression call. So we first look up the actual body, right, of the expression of the function that we're about to call by ID. Once we get that and we verify that it is a function, then we try to evaluate the function, right, itself. So this will be like evaluate the function application function call. To evaluate the function, we have some arguments and we have the body or the definition of the function, which right now is just a vector of clauses, right? To do that, we want to evaluate all the arguments first, right? And then we will create a new scope. In that scope, we'll try to match, right, one of the clauses. And once we find a clause that we match entirely, we will try to evaluate that clause, right, the body of that clause, and then we return that. So if we cannot match any one of the arguments, any one of the clauses, because patterns are just not matching, then we want to say we could not find a clause that matched these arguments, right? Otherwise, we would have found one of these clauses that matches the arguments you are providing, which means, yeah, which means we get the body and we can evaluate that. Which means this should return an expression. So here we'll get a result, and that will be whatever we are returning here. So when you evaluate the function, we push pop the scopes after evaluating in the middle, and then do that. But we'll need to make self mutable. Same here. Yeah, that's fine. I don't care. We will add more things. I need this thing to not blow up like that there. What are we missing? The value is moved here. Fine. Cargo test. Line 33, program items. What are you saying here? We need to borrow program. Okay, I'm okay with that. Cool. So that compiles. That means we are one step closer to having something that does run. Whew. But we're not yet using the interpreter anywhere, so we're just gonna write a couple of tests to see how we can make it work. Okay. So I think that if we get one test executing something, that will be the end of the stream for now. We'll come back to this sometime soon. Yeah, this doesn't have to be a great test. It just has to do something, right? So program, and we're just gonna say print, right? And then we'll get an argument like hello or arg. But we can't really do much with this either, right? So let's do something main, and we'll get an arg, and then in here we'll just call print, and we'll have to define what print is. Somehow. We also don't have any way of constructing or deconstructing data so that we can just run one iteration of this interpreter and get an expression back and say, oh, something happened. Okay. That's all right. We're just gonna say print, and we are going to actually define here a special case where if you call print, we're going to use the print macro to print all the arguments out. So that would tell me that yes, we can actually evaluate this code. Maybe even we can do some indirection here, right? Foo, we'll take arg. So foo. Okay. Parser, where are you? This is how you do things. Perfect. Test module, and this will be my program. Why are you complaining? Unclosed delimiter? What you talking, fool? One of 5? Oh, right. My bad. If the ID is equals to ID print, right, then we're literally just gonna call debug rx, and then we'll return an expression, literal string, and that's gonna be okay. What happened there? Why did it go away? Oy, oy, oy. So much hand waving things and shortcuts we're taking just to test something right now. We got a module there. That's great. We need to make an interpreter, right? And we'll do that from a module, right? And then we'll do interpreter.eval. And we're going to ask for an expression, which will be a function, a call actually. And the call will take an ID, and the ID is going to be main. And the arguments is going to be a vector of expressions, right? And these expressions are going to be literal strings, which will be hello world, and then garbage. Oof. More to string. This doesn't have to be mutable. How? This of course has to be mutable. We're calling m there. Okay, extra parentheses. Unused result, that's all right. We're gonna unwrap that. Cool. We don't need the return here, that's fine. We can remove the semicolon. What else don't you like? Cargo test, interpreter test. Oh yeah, that sounds like a really good idea. Or just implement into from string. I think that will also be convenient. Excellent. So this is doing something. There's an environment error there, right? We could not actually find the symbol called main, which I think is great because actually maybe it's not that great, but we're definitely doing something. Let's let's figure out what the environment is like right after we've I'm sorry, environment doesn't implement debug, of course. Why would it? Why would you do that? You don't implement anything. Why are you so lazy? Implement stuff. This is no bueno. I expected a lot more stuff to be in there, right? Environment. We are not getting here. Are there no items in that module? So debug, module, or program. We don't have anything. Okay. So that's a surprise. Why? I would have expected something. Like all of the parser tests will tell that this becomes a module, right? Let's declare bankruptcy there. Parser. Yeah. Look at this thing. Who are you fooling? Whoa, that works? I am agog. I am aghast. This runs, but this other program does not. So what happens if we do main, right? Like that. I'm gonna play around with that for a second. That still runs. We got the argument and everything. If I call another function called foo, what do you get? You still like it? Good. Okay. So if I define foo beforehand, right? And I say it takes an argument, and we will just call print without arguments, right? What would you do? No, I don't like this. Why do we have only one binding here? Okay. I know what the problem is. Parser for call. We don't actually have an example of this, right? A test for that. So when we go into parsing the function call, we have not actually parsed the parameters. So this is actually making that particular module item fail. And that's why it doesn't work. Sorry, Dima, I wasn't looking at the chat. Yeah, like as I guess now we're on the same page by now, but yeah, it was not a problem of moving things out of the program itself, since we're just cloning stuff right now here. So we just need to actually support that. And that's going to be pretty much like the function arguments. Actually, it will be the same thing, I believe. Except that instead of parse patterns, you will say parse expression. Args. And this will not be an empty vector, that will be that. Come on, do your thing. Seriously? Still nothing? Okay, so I'm gonna do one thing I was doing in the parser tests, which is just to assert that we don't have any diagnostics, right? And then this will blow up saying, oh my god, you have diagnostics, how dare you? I think we can call that there. No, never mind, I'll just make this public. Yeah. So this is giving me a parse error. We're gonna come into the parser and we're gonna fix that by adding a test for this. With a function call with arguments. And we're gonna put that code there. Actually, I just need one of these two lines. Or just that even. Parse call with arguments. Save, go back, run that thing, close this tab. Perfect. So what's the problem? We have a missing valid declaration, unexpected symbol found. We expected an ID, but instead we found brace right. Why did that happen? So when we do function call, we expect an open parentheses, right? And then we're saying if the current token is a parenthesis right, we can just break immediately. We know we're done. If it's not, we're gonna try to parse one expression, right? And then after that, we're just gonna save the expression in the argument list. And then we're gonna ask, do we have a comma? If we have a comma, we're gonna drop it and we're gonna go all the way back to the loop. If we don't have a comma, then we're just gonna end and then expect a close parenthesis. Because the only thing that can help us move on to the next expression will be a comma there. So I kind of would expect this stuff here, right? To be the thing that's failing. Maybe it's not. We expected to find an ID, but we didn't. Does this make sense? Yeah. A lot of convenience for sure. Three, 7, 8. I don't think the upper lowercasing is. Why am I even trying that? That makes no difference. So at this point, right, we have consumed the parents left, and we're about to consume the next token. And when we go into parse expression, we're saying pick on the current expression. If it's an ID, yeah, so our parser here sort of is thinking that if you have an ID, then it will always be a function call, which is not the case, right? We actually want to do a little more than that. I wonder if it would make any sense to actually extend the picking so you can say pick n, right? Yeah, actually pick is defined on top of the logos lecture here. And technically it does consume, but we're also saving that around. So what I'm thinking is whether it makes sense to be able to look ahead a little further up, right? Because right now we're saying, okay, is the current thing an ID, right? And then based on that, we're sort of going straight into parsing a function call, but that's not what we want. What we want to do is just say if it's an ID, then it can also just be an identifier, right? a variable that is being used. So if the next token from the ID is an open parenthesis, then yeah, this is absolutely for sure a function call. And I guess it's a matter of how we structure the AST here, right? Because you could say the function call. Could you say that there's a variable and we're trying to call that variable? Yeah, exactly. ID followed by. So here, for example, we could say, all right, you picked on the ID. That's currently saved. So when you call next, you're going to get that thing, right? You can pick again and it will still be the ID, right? But you want to pick one further down. Actually, maybe not. Maybe we just want to say ID, right? Is we just want to extract the ID there directly, like here, right? So we get the ID, and then we just pick again, like match lecture.pick is the next thing from the ID parentheses, right? Some token less parents left. If it is, then we will actually call this thing, right? Otherwise, we will just return an ID, a variable. So expression, and I don't actually think we have a variable right now in the parse tree. Call literal string variable. So when you do a function call, you actually have to tell us what the ID is of this function call. Which is not so terrible. Worse things have happened. That's what we have here, right? If you simplify it to ID, then parentheses, then it might work your way, much simpler. You mean make a new token that is both those things at the same time? Because right now I pick a token, and if it's an ID, right, then I know that it will be an ID. Now, depending on the next token, this ID may be used for a function call or just a variable, so I can just pick again, right? And if it's a left parentheses, then I just go into function call. This actually run here, and of course we have a small error in the assertion, but that's fine. That's expected. Like the thing that we were missing here is that the argument, right, will be an expression, a variable, right, that will have the ID, which will be arg to string. What do you mean a special func invocation token? Yeah, I don't have one either. Like I just have two tokens, the ID and then the open parentheses. And if I see them one after the other, then I know, okay, this is a function call. Cool, so that passes the test. Excellent. So I would expect now the interpreter tests to run. Yeah, okay, cool. Now we have different definitions there. Amazing. There's something that is broken here, and that's also very fine. It's part of the to-do, right? So I'm just gonna debug the current expression as it gets evaluated. and we don't need to debug the environment anymore because now things are being defined correctly, which is great. Perfect. So I evaluating this call to main, and the arguments are hello world and garbaggio. And I think what we need to do here is just define that expression literal string, right? Will evaluate to itself. So I wonder if I can just say like whatever you do, just return. Okay. Okay, expression. Yep. Yeah, I am. I'm writing the parser from scratch here, and the lexer is actually a wrapper around the logos lexer from the logos library, right? That lets me define a tokenizer from an enum. But I am actually in control of what's being picked and what not. So that I was thinking that maybe what I want to do is just say, you get pick one and then you get like pick many, right? And then internally, I just keep track of the things that you're picking, right? So then if you pick 10 tokens, they're not gone, they're there, right? They're still within the lexer. So you have to call next 10 times to flush them, right? But this also works. You pick one and then your logic tells you go here, go there. Because we could also say, all right, you have this token ID, and then the next thing, right, is like token parents left. So then it's a little cleaner maybe to do these patterns of long sequences of tokens that need to be in place, right? Worth playing around with. Okay, so we're running the test. We see the expression that we're evaluating, and then this is fine. But we get a clause match error because we are not actually if we do debug here, right, on clause and the args expression, can we even do debug with two things or more? Sorry, args. Yeah, we have a single one. Oops, my bad. We're calling main with two arguments, but it just has one. So I'll just remove garbaggio and go back in. Haha! This didn't fail. It didn't do anything either, but it didn't fail, which is good, I guess. So now I would like this thing to actually print something out because it's not doing that. Printing stuff. And I guess that's because we have uppercase. No, we have print here with a single argument. This should be working. We should eventually get into this line, right? So I'm just gonna log that expression there. What? We're saying eval, expression call, ID main, right? Surely we should see at least this debug. Right? But we don't see anything. Our program is indeed executing. Bam, look at that. But that's not what we want. We want to actually evaluate the arguments. And so we want this in that call. Ay, ay, ay. Args experts. Come on, do it. No. Sorry, folks. I'm too tired now to think straight here. What we're trying to do is it should work because we're binding to the environment before calling eval, right? So if we actually do here as self.env, then we should see that the variable a should have been bound to hello world. No, this was bound to the other ID, so there is some indirection there. Yeah, this is a super long stream. I can't bear the thought of leaving this, not doing this one thing. I'll take a few days afterwards. So one thing we can do is that in the environment, right, if you do a lookup and you find an ID, then you just keep looking that up until you find something that isn't an ID, right? So if you find an ID to something, if let I expression, will it be an expression though? Bindings, ID, variable ID, yes. Expression, variable, right? ID. So if I am, like in this example, right, I bound arg to hello world and I am calling foo with arg, right? But at this point, the evaluation is not moving hello world, it's just moving the variable, which I don't really like. I think it's fine just so that we can not copy or clone big data structures, to just keep a reference to that variable in the other environment. But it might be a better idea to change this later, to have like a flat place, right, where all the data lives, and then here we just point to that particular thing instead of having to traverse the pointers through the whole stack, right? So when we do a function call here, and we call eval on each one of the variables, of course, when we have an expression that's a variable, then we will get an ID out of that, and that thing needs to be looked up in the environment. That's the problem. Env lookup id.clone. I mean, I say that, but I don't know, maybe that's not a problem. And I need to map error, interpreter error, environment error. There you go. So that should have the right error type. Okay, better, right? Here we're seeing the binding now actually has the value instead of just pointing to the other variable name. And here I wonder if we can get rid of that, because we're solving this at the binding level. Yeah, we could get rid of that. That looks good. Which means the next thing we just need to do to be able to intercept that function and actually do something with it, right, would be to just evaluate the arguments like we did before. Which, again, super hacky, not the thing that we want to do, right? But if I'm not mistaken, when I press enter now, we will see hello world. Boom, literal string, hello world. All right, set finit. That runs, that is it, that's a stream, that is this stream. Whew. Damn. That was intense. Look at that, brilliant. So I'm gonna copy this program actually to main queue. I'm gonna paste it there. And I'm gonna go to main, right? And we're actually gonna run that program. Wahahaha. And we are gonna get the first of the arguments. We'll definitely do that, Dima. Definitely do that. It would be so much fun to optimize some of these things with you. Fine. Almost there. So this will actually be interpreter. Come on. Interpreter, when you say self, you need to say mute self. Ah, excellent. So we don't really have a binary yet. I guess cargo toml bin. No, we don't really have that binary here. But if we go to target debug, right? Then we can say main queue. Oops. What? Target debug qlang. Huh. There we go. Hello world, everyone. Excellent. Okay. Now I'm for reals done. Jesus, almost 5 hours. Fuck. Sorry. Is it okay to curse on streams? Just realized I've never thought of that. Anyways, thank you so much, folks, for all the help, for all the support. Dima, Blaine, Pontus, you folks rock. All right, I want to close it. Stay safe, and I'll see you soon. We'll do next steps over Twitter or something like that. But I think it will be pretty nice to start working on the macro expander now that we have a little bit of an interpreter, right, that can do some things. Is he online? Yeah, let's do that. Let's raid Edu. Raid channel Edu. 1, 2, 3, here we go. Raid. Now. I don't actually know how rating works, so I am going to stop this stream. But you're more than welcome to go talk to Edu. He's great. See ya, folks.
Thanks for the raid. I didn't know that Ostero was was streaming. Hello. I actually don't know if I follow you. I do follow you. Starting a programming language. Oh no, please, not you too. Killing. Oh no. Let me get a GitHub. Killing. Yeah, I want to get some after the networking for Deku. I'm gonna get some work on Deku because I've been thinking a lot, and there is no way around it. Like the next generation of programming languages needs at least affine types, ideally linear types, because I've been looking at Antonio's code for HPAF, and it's pretty good. But there is so much mutation just to achieve, top-notch performance. And so I'm like, we need better than that. But I've been studying how to do linear types into Deka for a while, so. I just sent a message to Antonio. We definitely need linear types for fast code. Every piece of high performance code that I read /wrote end up with so much mutation that it's hard to keep track of the APIs. Imagine not having to fight bugs. In my defense, I don't fight a lot of bugs. Partial size. So the header buffer is gonna be about every time it's gonna be about the same. In this case, what do I need to do here? So this is the length of the message that I just received. Yeah, Blaine, you're gonna need to move to cross compilation. Get Nix and cross compilation for Windows. See ya, Alistair. Thank you so much.